Hi, this is Christy. You've spent a few weeks learning about fractions. So today we will take fractions a step further and talk about ratios. A ratio is a comparison of two numbers. For example, if you have 2 adults for every 5 children, you say the ratio is 2 to 5. You can also write it like this, 2 to 5, or put it in the form of a fraction, 2 over 5. You say them all the same though, 2 to 5. Look at the following picture. What is the ratio of blue squares to yellow squares? Blue squares, 1, 2, 3. Yellow squares, 1. 3 to 1 is the ratio. Now let's mix it up. What is the ratio of yellow squares to blue squares? Now the key when you're writing ratios is to notice which has been written first. Yellow squares to blue squares. Yellow squares was written first, so you put that first. There's 1 yellow square. Next comes the second thing that was written. Blue squares, 1, 2, 3. Now the ratio of yellow squares to blue squares is 1 to 3. I'd like you to make your own ratios. Use your own household, whoever lives in the house or apartment with you. What is the ratio of adults to children? Go ahead and figure that out. And you can hit pause on this video whenever you want if you need more time. Since I don't have you in class, we'll have to do mine. Let's do my house. Adults to children. 2 adults live in my house. And 3 children live in my house. 2 to 3. Now what is the ratio of people to bedrooms? And again, you can hit pause. In my house, there are 5 people and 4 bedrooms. The ratio is 5 to 4. How about adults to cars? In my house, there's 2 adults and 2 cars. But this is interesting because just as if this were written as a fraction, you can reduce it. 2 over 2 is the same thing as 1, isn't it? If you divide the top number by 2, divide the bottom number by 2, you'll get 1 over 1. So in my house, the ratio of adults to cars is 1 to 1. Each adult has a car. What's the ratio of people to TVs in your house? In my house, there's 5 people and 3 TVs. That's kind of embarrassing. That seems like that's a lot of TVs. Okay, moving on. Brainstorm some more ratios that you use in your everyday life. Go ahead and press pause here, and I'd like you to think of some ratios that you use in your everyday life or your work. Moving on, I'm going to list some ratios that I've had students say in the past. Someone said the ratio of baby formula to water. And that's really important because you want the consistency to turn out just right. You might not know, but if you use too much baby formula and not enough water, your baby can get constipated. Or if you use too much water and not enough formula, your baby's not getting the nutrition that it needs. You need to keep the correct ratio. Ratio of baby formula to water. What about money? How about the ratio of the dollar to the peso? I think it's about $1 to 16 pesos. That's a ratio. It could be something as simple as the amount of sugar in your coffee, however many cubes or packets you like. Ratio of sugar to coffee. I've had someone say the ratio of water to cement. If you don't get the ratio right, the cement might be very runny, not very sturdy. just do, how about the amount of medicine, like say Tylenol, to weight? If you have a kid and you've ever had to give a kid Tylenol, you know you have to look at the box and find out how much they weigh, and then it tells you how many teaspoons. And the last one's a little complicated, but I've had someone mention this to me before. What about when you have an HVAC or a heating system in your house? What about the ratio of how efficient it is? It's the amount of heat put out to the amount of energy required, the amount of energy needed. Just look at that for a second. You want this number to be high, don't you? And this number to be low. You want to have more heat put out that required not a lot of energy to do so, because that would make it cheaper for you. Anyway, I said that was complicated, but it is interesting. When using ratios, if your answer gives you an improper fraction, like top-heavy, that is okay. So this is one example where you can leave a fraction top-heavy. And by top-heavy, I mean, say it's a 3 on the top and a 2 on the bottom. Normally, you would have to reduce that. You would make that 2 and 1/2. I'm sorry, 1 and 1/2. Let's use this example. For example, if you have 4 cans of corn and 3 cans of peas, the ratio of corn to peas is 4 to 3. Write that 2 other ways. And if you look back at the top of the notes, I showed you the 2 other ways. In addition to just spelling out the word 2, you can use the colon or you can use the fraction. So let's try that now. The ratio of corn to peas is 4 to 3. 4 to 3. And now we'll use the fraction. 4 to 3. And you see I don't have to reduce this. If I did, it would be 1 1/3, but that doesn't sound right. The ratio of corn to peas is 1 1/3. No, cross that out. The ratio of corn to peas is 4 to 3. Move on to your second page. Let's do a problem from our homework. This is page 106, number 1. Write the ratio as a fraction in lowest terms. And they gave you 6 to 8. Let's read that again. Write the ratio as a fraction in lowest terms. Okay, I see I need to have it in fraction form. Let's go ahead and do that. 6 to 8. I feel pretty confident about that. From page 1, I know that 6 to 8 is the same thing as 6 to 8 this way. But lowest terms means we have to reduce it. You could divide both of these in half and you would get the right answer. Or you could just say, let's do the same thing to the top and the bottom. Now you're remembering back to fractions. 6 divided by 2 is 3. 8 divided by 2 is 4. Now we have an equal fraction. 6 to 8 is the same thing as 3 to 4. And we just proved it here. 6 to 8 is the same thing as 3 to 4. Equal fractions. Now let's do a ratio word problem together. It always comes back to word problems, doesn't it? And here it is. In a class with 18 students, there are 2 left-handers. Everyone else is right-handed. What is the ratio of left-handers to right-handers? Okay, when I work with a word problem, I often will want to somehow bring out the numbers. I know there's 18 students in all, and 2 are left-handers. Everyone else is right-handed. Can we get a number out of that? Everyone else, 18 students in all, minus the left-handers, should leave me the number of right-handers. 18 minus 2 is 16. So 16 right-handers. It's nice just to have that up there. What is the ratio of left-handers to right-handers? Now here's the two. What you read first must go first. Left-handers must go first, 2. And right-handers comes next, 16. Now I don't know if you can tell or not, but that is the same thing as 2 over 16, which is a fraction. You can reduce that. Let's just divide that in half. 2 divided in half is 1. 16 divided in half is 8. So the ratio of left-handers to right-handers is 1 to 8. What is the ratio of right-handers to left-handers? And here I'm trying to get you to realize that whatever you read first must come first. The ratio of right-handers, 16, to left-handers. Go back and find your number, 2. 16 to 2. If you'd like to look at it this way to decide if you need to reduce, go ahead. Let's divide everything in half. 16 divided in half is 8. 2 divided in half is 1. And in the case of a ratio, you would just leave the 1 there. It sounds better. The ratio is 8 to 1. Also looks like this, 8 to 1. Now, what is the ratio of left-handers to the total number of students? Left-handers came first, 2. The total number of students, 18. 2 to 18, which you can also do like this. And let's reduce. We'll go back to doing one the technical way. Do 2 and 18 share any factors? They do. They share 2. Divide the top by 2 and the bottom by 2. 2 divided by 2 is 1. 18 divided by 2 is 9. So the ratio of left-handers to the total number of students is 1 to 9. Good. Now, let's talk about something a little bit more complicated, which is a rate. I think ratios is fairly easy, but a rate is a little bit more complicated. Sorry about that. A rate is a special ratio in which the two terms are in different units. For example, miles per gallon is a rate. Can you think of any more rates? How about heart rate? Heart rate is actually given in beats per minute. And how about speed? Speed, or rate of speed, is given in miles per, do you know? Hour. Now how about pay? Rate of pay. Pay is given in, I bet you could fill this one in, dollars per usually hour, sometimes a day, sometimes a week, if you're salaried, even sometimes month. But I'm putting dollars per hour. These are examples of rates. Everything is measured differently. You measure the beats, and then you measure time. You measure the distance, and then you measure time. You measure the amount, and then you measure time. That makes a rate. We use rates every day. For example, driving 60 miles per hour or making $500 for a 40-hour work week are all rates. Write them out so you can see that the units are different. So 60 miles per 1 hour. That was this one here, miles per hour. Now let's do this one. $500 dollars, and I'm just writing everything out so you can see, dollars per 40 hours. Those are rates. Now rates are usually reduced over 1, like this, 60 miles per hour, such as 2 feet per second, that means per 1 second, or 5 miles per hour, that means per 1 hour. To make this point, I want you to circle the sentence that sounds right to you. Which one do you like the sound of better? I drove 120 miles per 3 hours, or I drove 40 miles per hour. I have heard this a lot more, 40 miles per hour. But notice it's talking about the same rate, but the second sentence has just reduced the fraction. Let me show you that these are equal fractions, or that the ratios are equal. 120 miles per 3 hours, 120 divided by 3. If you did it on a calculator, you get 40. It's just been reduced. Let's move to the third page now. Rates are used to solve many real-world problems. Let's look at one of your homework problems together. Page 109, number 3. Valley Car Rental has a 5-day car rental package for $165. What is the daily rate that Valley is charging on this package? Now this is important. Like, let's say you're on a vacation, or you're going to visit family, or even going on a business trip. You might have quotes from different companies that aren't even talking about the same number of days. If one company says, oh yeah, I'll charge you $165, you say, okay, how many days? They say 5 days. What if the next company says, oh yeah, I'll charge you $165, but what if they're talking about 2 days? Obviously, the first company would be a much better deal, right? Well, let's just prove that. To figure out how much it is per day, you have to set up a ratio of price per day. You take the price, $165, you put it over the number of days. Let's use a calculator. $165 divided by 5. 33. That would be $33 per 1 day. And we just reduce the fraction so that 1 day is on the bottom. Now let's do another problem that you might encounter while shopping at Walmart. This is a little bit more complicated, but this is an important one to know how to do as well. A sign says 3 deodorants for $2.70. It's such a great deal that you want to buy all the deodorant that is left. There are 10 deodorants left on the shelf. How much would all 10 cost? Maybe you want to make sure that you have the money before you go up to the cash register. To solve the problem, you need to do the same thing that you did up here. Find the price for 1 unit, or the price for 1 deodorant. And then once you find out that, just multiply by 10. So how do you find the price for 1 deodorant? The same thing that you did up above. You're going to take $2.70, but that was for 3 deodorants. Let's write that out. $2.70 was for how many? Was for 3 deodorants. And just as we did up above, we'll get our calculator out and we'll do that division. $2.70 divided by 3 gives me 0.990 cents. 0.9. And that's for 1 deodorant. We have reduced it down. $2.70 divided by 3 was 90 cents. And now you have to multiply to get how much would all 10 cost. Let's get our calculator, even though you probably can do it in your head. We have 0.9, let's multiply by 10. And it comes to 9. 0.90 times 10 came out to 9. $9 for all 10 deodorants. Good. Now finding the cost of one unit first makes it easy to find the cost of multiple units. And I really want you to learn how to break down prices like this. That will actually help you whenever you're shopping or buying anything really. If you can find out how much the price is per one, then you can quickly multiply and figure out how much it would be, say, for 10 or 15. All right, great job.